Hello everyone, welcome to our YouTube channel Logic Medico. Today's interesting topic for presentation is the development of the ear. So development of the ear starts as early as 4th week of intrauterine life in the future head and neck area at the junction between the first arch and second arch. Initially there is one thickening, it's called as otic placode. So where is it present? At the future junction between head and neck area. This otic placode is an ectodermal thickening. Initially, the ectodermal cells rapidly proliferate to form a thickening on the ectodermal surface. Subsequently, it will get canalized like this and it will move to the inner aspect. So what is that inner aspect? It is a pittrous part of temporal bone. So it moves inside the skull. So this portion is now called as otic vesicle. So what happens to the otic vesicle subsequently? What is their vesicle? This vesicle will get canalized to form like this. It's called the cochlea. Then becomes one small cubical chamber. It's called the vestibule, and becomes three half moon like canals. It's called the semicircular canal. So what does the otic placode contribute to? It contributes to the inner ear. Where is it located? In the pittrous part of temporal bone. So from this otic placode, bipolar neurons will develop. This is nothing but vestibulocochlear ganglia. To be more specific, it's called vestibular ganglia and the cochlear ganglia. They are bipolar neuron. The peripheral process will go towards the ear, the receptor for hearing. The central process goes towards the brain. So that is the bipolar neuron. So these bipolar neurons are also developed from the otic placode or the ectodermal thickening. So they are called as cochlear ganglion, which is carrying the nerve impulse of hearing. The vestibular ganglion is carrying the sense of balance. So that is about the development of inner ear. Now what happens subsequently within this endodome, that is in the oral cavity? Just stretch out your tongue. This is the endodome. The first pouch and the second endodermal pouch, the dorsal portion of these two pouches will unite with one another to form a rhesus. It's called as tubotympanic rhesus, which I tell in a simpler term. It is called as TT rhesus or tubotympanic rhesus. So what is this tubotympanic rhesus? It is a portion of the endodermal pouch. Which pouch? The first and second endodermal pouch. What are these pouches? These are pharyngeal pouches which are there on the inner surface of our pharynx. Okay, so they join to form one rhesus called as tubotympanic rhesus. Initially the tubotympanic rhesus is dilated throughout. Subsequently what happens? The proximal portion becomes narrow while the distal portion will become dilated. So this narrow portion gives rise to the tube. So what is the tube? Eustachian tube. The distal portion gives rise to tympanic cavity. So the fate of tubotympanic rhesus is that the proximal portion will give rise to tube called as Eustachian tube. The distal portion gives rise to tympanic cavity or the middle ear cavity. Okay, so from this tympanic cavity or middle ear cavity, what happens subsequently? There is one diverticulum coming out, and that is nothing but mastoid antrum. So Eustachian tube, tympanic cavity or the middle ear, and mastoid antrum, all these are developed from tubotympanic rhesus, which is the dorsal portion of first and second endodermal pouches. Okay, so this is a contribution towards middle ear. In addition to this, what happens? There are three ossicles: the malleus, that is a hammer; the incus, that is anvil; and the stapes, that is a stirrup. These are together called as ossicles because they oscillate within the middle ear. So these malleus, incus and stapes, out of these three, the malleus and incus is developed from cartilage of the first arch. It's called as Meckel's cartilage. Meckel's cartilage. Whereas the stapes develops from the cartilage of the second arch. Second arch is called as Richter's cartilage or Richard's cartilage. Richard's cartilage. Richard's cartilage. So malleus and incus develops from the cartilage of the first arch, which is Meckel's cartilage, whereas stapes develop from the cartilage of second arch, which is called as Richard's cartilage. Now there are two muscles in the middle ear. Attached to the malleus will be one muscle. It's called the tensor tympani. This tensor tympani is developed from first branchial arch. The nerve for the first branchial arch, the proof for this, the nerve supply for the first branchial arch is mandibular nerve. So this mandibular nerve supplies the tensor tympani. So that is a proof that the muscle is developed from first arch. Okay. So tensor tympani, it's called so because it pulls the handle of malleus inwards. Therefore the tympanic membrane will be tensed. And that's why it's called as tensor tympani. The next muscle will be next to the stapes. It will hold the neck of the stapes. It comes from the posterior wall of the tympanic cavity within a conical projection called as pyramid. This muscle name is stapedius. So this stapedius muscle is developed from second arch. The proof for this is the nerve supply is coming from facial nerve. Facial nerve is the nerve of second arch. So stapedius is another muscle. It is coming from the pyramidal process or the pyramidal eminence. It's attached to stapes, therefore it's called stapedius. This muscle is developed from second branchial arch or pharyngeal arch. The nerve of the second branchial arch is the proof for that because facial nerve supplies this muscle called as stapedius. So the middle ear development is mainly from the tubotympanic recess. The ossicles out of this malleus and incus develops from the Meckel's cartilage. Stapes develops from the Richter's cartilage. Tensor tympani develops from the first arch. Nerve supply for that mandibular nerve. Stapedius develops from second arch. Nerve supply for that is facial nerve. Now what happens in the outer surface of the head and neck? There is one arches, no? Mandibular arch, hyoid arch. There are arches which are developing the outer surface of the head and neck. Between these so-called pharyngeal arch or branchial arch, there is a depression. This depression which is there, no? It's called as first ectodermal cleft. So obviously the first ectodermal cleft will be there between the first arch and the second branchial arch. This ectodermal cleft will deepen to give rise to the external auditory canal. So first ectodermal cleft give rise to the external auditory canal. Around this first ectodermal cleft there are certain mesodermal swellings which are approximately 5 to 7 in number, minimum 5, maximum 7. There are swellings which come around. These swellings will unite ultimately to give rise to the pinna. So these swellings are called as mesodermal hillux. What is it called? Mesodermal hillux. Mesodermal hillux will give rise to the pinna or the auricle. Deep to the pinna or the auricle is the first ectodermal cleft. So this first ectodermal cleft, gives rise to external auditory canal. So in summary, the development of the ear, I can summarize this one. This is a otic vesicle give rise to the inner ear. This one. Okay. Inner ear includes cochlea, vestibule, semicircular canal. Next, this is the tubotympanic recess, which will give rise to the eustachian tube, the tympanic cavity, and the mastodantrum. These are the ossicles. Malleus and incus developing from Meckel's cartilage, whereas stapes is developed from Richter's cartilage. And this is the first ectodermal cleft that is giving rise to external auditory canal. Here there will be swellings 5 to 7 in number giving rise to pinna. The junction between the first ectodermal cleft and the tubotympanic recess, over here there will be formation of tympanic membrane. So tympanic membrane has got three layers. Outer cuticular layer is developed from ectoderm, inner mucous layer is developed from endoderm, whereas the middle white color, can you see here, white color area, that is derived from the intermediate mesoderm, the connective tissue layer or the fibrous layer. So tympanic membrane is a structure in the body which is developed from all the three germ layers. I repeat, outer layer, outer cuticular layer developed from ectoderm, inner mucous layer is developed from endoderm, the intermediate fibrous layer is developed from the intermediate mesoderm. So this is about the development of the ear in detail. Thank you for watching this video. Kindly subscribe to our channel and press the bell button to get the latest notification of the videos. Thank you once again from Learning from Logic Medico.